Okay, we are back and better than ever. We are talking about vectors in the plane. Um, I think it's really important that we have a good visual of what exactly are vectors in the plane. So I have three really good examples here. Here we have three vectors in the plane with some other people in the plane, but the vectors are still seated. What else? Here we have a vector sleeping in the plane while another vector is rushing to the bathroom in the back of the plane. And then the last example we have of vectors in the plane are here. These are actually pilots. Here is the captain. He's in charge of the flight, and then here or the pilot, I guess. And then this is the co-pilot. These two vectors. So those are some good visuals of vectors in the plane. When we plot points in the Cartesian plane, we move first in the x direction and then in the y direction. In other words, to plot the point 2, 5, we would start at the origin. You guys know that. Move 2 units to the right and up 5. Well, if I was going to draw the vector represented by 2, 5, then I'd start at the origin and go to that final point there. So right there is the vector 2, 5. In transformation geometry, translating a point, A units in the x direction and B units in the y direction, can be achieved using the translation vector AB. This is called component form. Okay. So the component form for vector OP, O for origin and then P, is 2, 5. Pretty nifty. Very easy way to think about things. And now we have two very special vectors, I and J. I is a translation 1 unit in the positive x direction, 1, 0. The positive x direction only. And J is a translation 1 unit in the positive y direction. So 1 unit is represented in the vertical position of the component form and no translation in the x direction. So if we only moved in units of moved 1 unit at a time, then we would move 2 i's to the right and 5 j's to be able to draw the vector OP. So another way we can represent vectors is this form. Okay, OP equals 2i plus 5j. So why is that? Well, 2, 5 equals 2 multiplied by 1, 0 plus 5 multiplied by 1, 0. If you just look at the easy arithmetic with that, multiplying by 2, I get 2 times 1 is 2, 2 times 0 is 0, 5 times 0 is 0, 5 times 1 is 5, and that's where we get the component form of 2, 5. Oops, sorry. And next, we just have some definitions. The point Pxy has position vector OP equal to xy or xi plus yj. That's the same thing as x equals what we just did, 2i plus 5j. Okay? I is the base unit vector in the x direction, and j is the base unit vector in the y direction. And this is the standard. We use I and j all the time, and it makes it easier to write vectors in many instances. Okay, and this is for two-dimensional vectors. We will get to three-dimensionals a bit later. Okay, all vectors in the plane can be described in terms of the base unit vectors I and j. So, for example, this vector right here is 3i because it's 3 units in the positive horizontal direction, minus j because it goes down 1 unit in the vertical direction, and down is negative. And then we get our vector, vector A, right there. B is negative 4i, 4 units to the left, plus 3j, horizontal, vertical, draw our vector. This should make sense. Two vectors are equal if their components are equal. Okay. So we have unit vector form, we have component form. It's awesome with a capital A. And so we're going to write OA. Anytime you have an O, that is the origin. And CB in component form and in vector form. So let's do OA is going to be equal to, we'll do component form first. OA, how many horizontal and vertical movements do I need to make to get to the endpoint of the vector? 1, 2, 3 positive horizontal shifts or translations and 1 vertical shift. So that component is 3, 1. And so that's component form. And in unit vector form, that's 3i plus 1j. So plus j is fine. And here's a little step you don't see really. Well, here, let me do this. This is equal. We've answered the question here and here, but I just want to again reiterate that's what this means is 3 times 1, 0, plus 1 times 0, 1. So this is 3, 0 plus 0, 1. And 3 plus 0 is 3, and 0 plus 1 is 1. And we're right back to component form here. But all of this is what this means. So for CB, that is going to be, let's see, from C to B, 1, 2, 3 units to the right, and 1 unit up. Wow, looks familiar, doesn't it? 3i plus j. And B says, comment on your answers in A. Well, the vectors, they're equal. They have the same components. Now, the interesting thing, and that what you have to realize, it doesn't matter where a vector is on the coordinate plane. If they have the same components, same direction and magnitude, basically, then they are equal vectors. Easy peasy pumpkin pie. Becker is out.